Okay, now next topic of this series, metrology and instrumentation, that is gear metrology. Gear metrology is very much important for mechanical engineers or the mechanical based industries because gear is very common component in any mechanical system and complex as well, because so many features are there which are very difficult to measure by linear or angular measurement instruments. That's why it is very much important to learn about gear metrology. How do we check different dimensions of any involute gear? Will be only discussing about involute gears, not cycloid gears, because involute gears, they are very much common in industries and they are more frequently used in mechanical systems. So let us start. This would be our content. First of all, we'll try to understand basic terminology for involute gear teeth or involute gears. Then after, a very much important feature of gear is gear tooth thickness. So we'll discuss three methods in this series for gear tooth thickness error measurement. And last one is a rolling test, very popular test in industries, where we are using Parkinson gear tester. So in rolling test, we'll discuss what are the features we can measure and how to perform rolling test. First of all, the basic question is how to generate tooth profile, involute tooth profile. So here in this diagram you can see, one circle which is called as a base circle. Now basic definition of involute is, if you consider one line which is tangent to base circle, if you roll line tangent to any base circle without slipping, and if you trace end point of that line, then that generates involute profile. So if you consider here G1 R1 line, if you roll G1 R1 line on base circle, the next tangent point or the contact point between base circle and this rolling line would be R2. At that time, this G1 point that shift to G2, and this process continues. Means after R2, next point somewhere here you get R3, then end of that line that will be on this curve, involute curve. So this is how involute profile of any gear teeth is generated. It is with respect to base circle. So as per the involute property, what we can say, if you just another definition of involute is, if you consider unwinding of any thread from the periphery of circle, and if you trace end of that thread, end point of that thread, then that also generates involute profile. So you can consider one thread that is wound around base circle. Now just try to unwound it. So suppose this G1 point is the point from where we are starting unwounding of thread, and we need to keep thread tight. So as you open thread from point G, then G to G1, that is the next point, then G1 to G2, that is the next point. So we are unwounding thread, then end point of that thread that is this curve, that also generates involute profile. Okay, so as per this definition, what we can say, GR1 is the arc length, then GR1 arc length is equals to G1 R1 line length. Similarly, GR2 arc length is equals to G2 R2 line length. This is what the basic principle of any involute curve. This will be helpful to us in few derivation which we will be discussing under this topic. So that's why it is very much important to remember this arc length is equals to tangent line length. Now we move further. Now terminology for involute gear teeth. So here you can see this dark gear wheel. So many gear teeth are considered. Opposite to that, you can see one light dotted gear wheel. So two gear wheels, they are in mesh. Now one by one, we'll discuss different terms. Very first is the base circle. So in previous slide, we have seen what is base circle. Base circle is the reference circle about which we are drawing involute profile. So suppose if I consider this gear teeth, then this profile is generated by considering unbounding of any thread from this base circle. So that is the base circle. With reference to base circle only, we generate involute profile of any gear. Next is pitch circle. What is pitch circle? In calculations of gears, we consider one imaginary circle. This circle is actually not present, but this pitch line circle, this is called as a pitch circle. So in calculations, we are using pitch circle. Next point is circular pitch. What is the meaning of circular pitch? So if you consider length of arc of circle on pitch circle, which is cut by two similar involute profiles, this involute profile and this involute profile, two similar involute profile of two successive teeth of any gear wheel. That is called as a circular pitch. I am repeating again. It is length of arc on pitch circle, cut by two similar involute profiles of two successive gear teeth. That is called as a circular pitch. So this length of segment of circle, pitch circle, that is called as a circular pitch. So basic equation of circular pitch is pi d by n, where d, this capital D stands for pitch circle diameter, and divided by n, n stands for number of gear teeth present on any gear wheel. So this is how you can find out this length. It's very simple. Logic is pi d, that will give you length, peripheral length of pitch circle. If you divide that peripheral length by number of teeth present, then that will give you length of this curve. Okay. And in this equation, you can see one another nomenclature, that is small m. Small m is called as a module of gear. So here you can see module is equals to d by n. So here pitch circle diameter divided by number of teeth, that is called as a module. So here pitch circle equation is replaced as pi m, because in design calculations of gear wheel, generally we are using module. That's why this another equation is given. Next term is tooth thickness. So if you see in this pitch circle, this much of portion, that is blank portion, space portion, and this much of portion is actually teeth portion. So whenever meshing between two gears take place, then in this space, opposite gear teeth that entrap, and due to that you get a motion transmission between two gear wheels. So half of circular pitch, that is called as a tooth thickness. Yeah, so this much of length, that is called as a tooth thickness. Similarly, next point is space width. So remaining half portion of circular pitch, which is blank on any gear wheel, so it is actually length of arc between two gear teeth, that is called as a space width. So circular pitch is equals to twice of tooth thickness or twice of space width. Next is addendum. What is addendum? If you consider two circles, first of all two circles, one is pitch circle, this is called as a pitch circle, and second is addendum circle. Addendum circle is again imaginary circle which is passing through top length this extreme end of any gear teeth, that is called as a top line. So this circle, that is called as an addendum circle. So this is called as the addendum circle, circle passing through top of any gear teeth. Then what is addendum? Addendum is a radial distance, this radial distance between pitch circle and addendum circle, that is called as a addendum. Similarly, now next is clearance. To understand this clearance, let us first of all discuss clearance circle. So what is clearance circle? See, for avoiding interference between two gear wheels, some fillet radius is given at the bottom of gear teeth. So from where fillet radius starts, if you consider one circle passing through that point, then that circle is called as a clearance circle. Okay. Then distance between clearance circle and dedendum circle, that is called as a clearance. So this much of distance, that is called as a clearance. What is dedendum? Dedendum is radial distance between addendum. Okay, before understanding dedendum, let us see dedendum circle. What is dedendum circle? So this circle, this lowest most circle, which is passing through bottom length, means the root of any gear teeth, that is called as a dedendum circle. So this is called as a dedendum circle. And radial distance between pitch circle and dedendum circle, this radial distance, that is called as a dedendum. Next is working depth. So working depth is nothing but radial length of any gear teeth. So it is radial distance between addendum circle and dedendum circle. So this much of overall length, that is called as a working depth of any gear wheel or gear teeth. Next is about face and flank. So as I discussed, this involute profile of any gear teeth, that is generated by taking base circle as a reference, then this involute profile is actually split into two parts by this pitch circle. This is called as a pitch circle. Yeah, it is. So intersection between this pitch circle and involute profile of gear wheel, this point, this intersecting point, that is called as a pitch point actually. Then distance between top line and pitch point, this involute profile, which is between pitch circle and addendum circle, that is called as a face. And remaining half involute profile means involute profile between pitch circle and dedendum circle, that is called as a flank. So that entire involute profile is again split into two parts. One part is called as a face and second part is called as a flank. So these are the basic terms related to any gear. Now next is about line of action and pressure angle. These terms are very much important. This will be helpful to us to understand basic derivations for this course or for this topic. So here you can see two gears are shown. This gear teeth of one gear and opposite gear teeth for opposite gear wheel. So motion transmission taking place between two gear wheels. We have only considered two meshing gears. So this is one gear teeth for gear 1 and this is another gear teeth of gear 2, which are mesh. Now here you can see two arcs. This arc, that is called as a base circle, and this arc, that is called as a pitch circle for gear 2. Similarly, you can see one segment of circle. This segment of circle is called as a base circle for gear 1. Similarly, this segment of circle for gear 1, that is called as a pitch circle. Okay, and these are the two gear wheels. Then you can see here one line, this line, So what is first of all line of action? You can clearly see in this animation, when motion transmission taking place between two meshing gears, then if you look from this point, engagement starts between two gear teeth and that ends somewhere here at this point. Then that through that engagement between two gear wheels, that is in this line. So this line, that is called as a line of action. This red line, that is called as a line of action. So line of action is actually tangent to both the base circle of two meshing gears. So here same is indicated. So this is base circle 1 and this is base circle 2. Then you can consider this line which is tangent to both the base circles. Then this line is called as a line of action, because along this line meshing between two gear teeth that is taking place. Okay, so relation between pitch circle and base circle. Here one another term, that is pressure angle. So here you can see one right angle to this point P. This point P is called as a pitch point, because if you look here, engagement start here and that is up to this blue line. Then at this blue line you get a midpoint of any involute profile, because in previous slide also I discussed about pitch point, because from pitch point two portions of involute profiles are described. One is a flank and the second is a face. So this point, when this engagement comes to this central line or the center line between two meshing gear, then this point where right now cursor is present, that point is called as a pitch point, which is indicated here by letter P. So this is pitch point. Yeah. So here you can clearly see one right angle triangle is formed. This contact point A dash, which is a contact point between this tangent and base circle. Then if you consider this half portion of line of contact or line of action, this continuous from this point to this point, you get line of action. And pitch point divides equally this line of action, this portion and this portion. Then you see here this A dash to P, P to O and O to A. One right angle triangle is formed. Then you get here angle phi, which is angle between normal to contact point, one line normal to contact point O A dash and this center line. Then angle between these two, that is called as a pressure angle. Similarly, so this is what called as a line of action and this phi angle. Similarly, pressure angle can also be defined by angle between these two lines. One is line of action, and if you can see here, one line which is tangent to both the pitch circles and passing through pitch point, this horizontal line. Then this line and line of action, angle between line of action and pitch line, that is also called as a pressure angle. This angle is also called as a pressure angle. So here you can see this phi. So if you consider this right angle triangle, then O to A dash line is the radius of base circle, because this is the segment of base circle. So O to A dash, that is radius of base circle, and O to P, that is called as a radius of pitch circle, because P point is present on pitch circle. So O to P is radius of pitch circle, which is indicated by RP and RB here. So RP is the radius of pitch circle and RB is the radius of pitch circle. So looking to this right angle triangle, if you apply cosine rule, then cos phi is equals to OA dash, which is RB, divided by hypotenuse OP, which is RP. Then we get this relation RB is equals to RP cos phi, because in design calculation generally phi pressure angle is known and RP pitch circle radius is known. Then we can find out what is the RB. So this is the relation between RB, RP and phi. Relation between base circle radius, pitch circle radius and pressure angle. Next relation is about circular pitch. This is what we discussed in previous slide also. Circular pitch is equals to pi dp by n. Pi dp is the base circle pitch circle diameter, and n stands for number of teeth on gear wheel, and same is replaced by pi m. M stands for module. Module stands for dp by n. Then tooth thickness, as we discussed in previous slide, half of circular pitch, that is called as the tooth thickness. So pi m by 2, that is tooth thickness. Now base circle, base pitch, if you consider segment of base circle between two, cut by two successive involute profiles of two successive gear teeth, then that is called as a base circle pitch. So here you have pi dp by n, equation for circular pitch. Then for base pitch, it's a pi db by n. Let me try to indicate you what is pi db by n in previous slide. So here you can see on base circle, if you just consider this as a base circle, then base circle pitch or base pitch is how much? Then if you consider this as a circular pitch, portion of pitch circle which is cut by two similar involute profiles of two successive teeth. Similarly, if you consider same segment on base circle, this is your base circle. So a segment of base circle which is cut by two similar involute profiles of successive teeth. So from this point to this point, this is called as a base circle pitch or base pitch. This is called as a base pitch. Yeah. So relation between base pitch, equation for base pitch is pi db by n. And again, if I replace db by dp cos phi, then pi dp cos phi by n, that is equation of base pitch. This relations will be helpful to us for some derivation. That's why we are discussing these relations. So please try to remember this relation. These are the empirical relations for gear design. This will be also helpful to us. Generally, these two gear wheels with two different pressure angles are used in industries. One with pressure angle 20 degree and second with pressure angle 14.5 degree. 14.5 degree pressure angle gear wheels, they are very much common. So here some empirical relations are given in terms of module of gear wheel. Addendum is equals to 1 module for both the pressure angle based gear wheels. Dedendum, if 20 degree pressure angle, then it is 1.25 times module, and if pressure angle is 14.5 degree, then dedendum is equals to 1.157 times module. Then similarly for working depth, hole depth, circular teeth thickness, fillet radius, clearance and face width, empirical relations are given in terms of gear module. So this will be again helpful to us in some derivation. That's why I have kept this standard table here. You need to remember that addendum is equals to 1 module for both the gears, and dedendum is equals to 1.25 times module for 20 degree pressure angle and 1.157 times module for 14.5 degree pressure angle. These two relations are very much important in our next derivations. That's why try to remember these two empirical relations. Next is about involute function. So let us try to understand involute function. If you consider one gear teeth, this is the single gear teeth on any gear wheel. This is called as a base circle. This segment of circle is base circle. This segment of circle is pitch circle. This is called as a pitch circle. These are the involute profiles. These are the involute profiles. So here, if you just consider this black color curve, then that is for gear 1, and this red color curve, that is the space of opposite gear wheel. So actually this image is indicating meshing between two gears. Then this image is the steady state condition when gear teeth of gear 1 is symmetrically meshed in the space of opposite gear. Okay, so this is the image of gear. Then you can consider this involute profile, then this is called as a face portion, this upper portion of involute profile, that is face portion, and this lower portion of involute profile, that is called as a flank. So as we discussed earlier, flank is involute profile between teeth circle and base circle. This is called as a flank. So you can see this is involute function. This is called as an involute function, which is indicated here in terms of delta and here in terms of rho. So this angle is called as a rho or delta, which is involute function. So you can clearly understand involute function is projected angle of flank portion of involute. Means if you connect pitch point with the center of gear wheel by this line, and if you draw another line from the root of involute profile to the center of gear wheel, then you get this segment. Then angle between these two lines, that is called as an involute function. Okay, so I think basic understanding of involute function is clear. Now here from this, these two diagrams are produced. First of all, let us try to understand this diagram. So we have now considered only one side involute profile. This is involute profile. Yahan, on this side we have considered two involute profiles. Means we have considered entire gear wheel, but now in this image we are only considering one involute profile. So this is involute profile of any gear wheel. Then this P stands for pitch point. This P stands for pitch point, and you consider A to P line, which is part of angle of action line, which we have understood in previous slide. So this A to P line is part of line of action, so which is common tangent, which is tangent to this base circle. This line A to P is tangent to base circle. So if I just try to correlate this image with the definition of involute curve, then you can consider one chord A to B. A to B is the one chord or one thread which is wounded on base circle. Now just try to unwound it. This B point is the end of the thread. I just try to unwound this thread from point B. Then that will trace this B to P curve. Then this B to P curve, that is called as the involute profile, and I keep thread tight. So A to P length is equals to arc length A to B. Here, so A to B is the arc length is equals to A to P line length, because this tangent is equals to A to B. Then we are getting here flank portion of gear teeth. So this is flank portion of gear teeth. And what is represented here, same we are doing here. This B is connected to center point of gear wheel, and this P is connected to center point of gear wheel. Same is indicated here. This P is connected to center of gear wheel, and this B is connected to center of gear wheel. Then angle between this line and this line, this is what called as the delta involute function. Why we are discussing it? Because again this term will be helpful to us to understand one derivation. That's why this term is very much important. So we are trying to derive delta equation of delta in terms of pressure angle. Okay, because delta is related to this pressure angle phi. Now you know what is pressure angle, because in previous slide during the discussion of line of action we have considered one right angle triangle PAO. So angle between line OA and OP is called as a pressure angle phi. So this angle phi is pressure angle, and this small angle delta is called as a involute function. I hope you understand this this drawing. Now from this, next is this drawing. So you can consider this is part of your base circle. This is part of base circle, and this portion is part of thread which is wound on base circle. Now let us try to understand how involute profile is generated, which we have already discussed in previous discussion. So this O is a center of base circle. Then this A is the point present on base circle, which is part of core. B is the end of thread or end of core, which is wound on base circle. Now what we are doing, we are unwounding it as shown here. A to B are, so same A to B are on base circle. Now we are trying to unwounding this thread B. We are keeping thread tight. The next point is point P. So P is a pitch point which is indicated in this drawing. So same P point here. Then this part is called as a flank of gear wheel. This part is called as a flank of gear wheel. So if I connect P with the O and B with the O, then angle between these two lines, that is what called as the involute function delta. And now if you draw one right angle triangle PAO, then this angle is called as a pressure angle. Same is indicated here, phi. So phi stands for pressure angle. So I think what I'm trying here, I'm trying to correlate involute definition with the gear profile. So looking to this diagram, what we can say, we can define this complete angle of segment arc AB. So as per the definition, angle is equals to arc upon radius. This total angle is phi plus delta is equals to arc B to A divided by radius, and this radius is of base circle. So here you can see angle, total angle alpha plus phi is equals to arc length, this arc length BA divided by radius r. Then what I can say, arc length BA is equals to arc length BA is equals to r into alpha plus phi, where r is base circle radius, alpha is involute function here right now, plus phi stands for pressure angle. Okay, so this is based on this. Now if you consider one right angle triangle, this right angle triangle, then tan phi is equals to rho by r. So we got one another relation from which we can derive this rho. So this rho PA is also equals to arc length BA. Both are same as per the definition of involute profile here. AP is equals to AB based on the involute definition. So P or the rho is equals to R tan phi. Now both rho if I equate, then I get R alpha plus phi is equals to R tan phi. Then R cancel out. Then remaining term, or I just simplify, alpha is equals to tan phi minus phi. Alpha is what? It's a involute function, this angle. So alpha is involute function. So involute function is equals to tan phi minus phi. So this is how we got relation between involute function and pressure angle. So involute function is equals to tan phi minus phi. Please try to remember this relation also. This will be helpful to us again in one of the derivation. Okay, so we understood involute function. Now in next session, I'll try to cover methods to check gear tooth thickness error. We'll discuss three methods. One is gear tooth vernier caliper method, second is base tangent method, and third is the constant core method. So one by one we'll discuss the three methods in our next session. So if we try to summarize our today's discussion, then what we discuss about why gear metrology is very much important for mechanical engineers, because gears are very much common fasteners or mechanical elements in any mechanical system, and they are very complex. Then second, we discuss about basic terminology related to gears. We discuss about how involute profile of any gear wheel is generated. We have discussed about line of action, pressure angle, and involute function. So we understood this basic terminology related to involute gears, and now in next session we'll be discussing methods to find out gear to thickness error.